Good morning, student. Today we will discuss about the mechanical properties of fluid, and we will see what are the basic mechanical properties of a fluid and how the fluids are different from solid. The volume of solid, gas and liquid depends upon the intermolecular forces. Also, the volume of solid, liquid and gas, liquid means fluid, depends upon the stress or pressure acting on it. It depends upon the how much pressure or stress is acting on that fluid or liquid. When we talk about the fixed volume of solid or liquid, we mean its volume under atmospheric pressure. In previous chapter, we saw the shear stress can produce change in volume. The key property of solid or fluid is they offer very small resistance to shear stress. They will not offer, liquid or fluid does not offer too much resistance to the shear stress. And we can say the shear stress is million times smaller in fluid than solids. Shear stress, you know what is shear stress? We saw when we take one cube and if the lower portion of the cube is fixed, so the tangential force is applied here. And if we apply tangential force, this portion will move like this. So corresponding to this, whatever be the stress, that stress is called the tangential stress. So that means change in the shape of solid will take place. But for the liquid, it's very small than solid. Now, a fundamental physical quantity that is related to the fluid. There are many properties that are related with the fluid, but one fundamental property which is related to the fluid is its pressure. You know what is the pressure? Pressure, it is equal to force upon area. Pressure, it is equal to force upon area, and the unit of the pressure will be Newton per meter square, or we can say that pressure P equal to limit delta A tends towards 0 F upon T. This is the pressure. Now, the normal force exerted by the liquid at any point we can measure with the help of pressure. And one small device we can use to measure the pressure of a liquid. See, if you take very big container here, and if we want to measure the pressure of the liquid, and say the liquid is here. So how can we measure the pressure of the liquid? To measure pressure, we can keep one apparatus there in this chamber, inside this, and that apparatus or the device which we will keep here will be such that it will consist one spring balance, So inside this we will keep one device which will be like this, and this is total evacuated chamber, no air, and it is fixed with the spring. And this is one box, you can see, and this box is connected with the piston. And here, now this is our device, and now we can see if this device is kept inside the liquid. Now this is the device you can keep here inside the liquid. So when we keep the device inside the container, then the liquid will exert the pressure. अब जब liquid, when it will exert the pressure, so this spring will compress. Here is inside this is the inside it. This spring device, it is here. So the liquid will exert the pressure and the spring gets compressed. With the help of that, we can measure the pressure exerted by liquid. By that way, we can measure the pressure. And it is very important physical quantity that its unit is Newton meter, and it will have Newton meter is the unit, and it will have dimension will be equal to Young's modulus. You know Young's modulus, y equal to mgl by pi r square. So that is its dimension. One more physical quantity that we encounter generally in fluid mechanics, it is called the density. Now what is meant by density? We all know in lower classes we have studied about the density. The density, it is the mass upon volume. This is very important physical quantity which we know. Density, it is equal to mass upon volume. So what is the unit of mass? Kg per meter cube. And density of water, see children, density of water is 1000 kg, and density of mercury, it is near about 13.6 into 10 to the power 3 kg per meter cube. Here also per meter cube. So important, the density of water at 4 degrees Celsius. Generally we take the density at 4 degrees Celsius. Then now we will discuss the Pascal's law. According to Pascal's law, the pressure is equally transmitted in all directions. To understand the Pascal's law, imagine this is one container, and inside this is container which will consist the water, and imagine this is imaginary prism. This is a prism, but it is the imaginary prism. Imaginary water prism. So we have imaginary prism which is made up of the water, and here we have A, B, C, and then you can extend it like this. So when we extend it, it will be like this. So in this case, we have different faces A, B, C, and then we have E, F. Here we have E and F. We have to prove that PA equal to PB equal to PC. Now this imaginary prism is kept inside the liquid. When it is inside the liquid, here the pressure force will act. Here also the force will act. Here the force will act, it will be FA. Here it will be FC, and here it is FB. This angle is theta, very small angle. Now see, this we can find the pressure and the component of force. Now this angle is theta, triangle is like this. So when this angle, this force vector is acting this side. This angle is theta, we can say that this angle is also theta. can you prove if this is theta, you can prove that this angle is also theta. So here in this direction FB is acting this direction. So when FB is acting this direction, it will have two components. One will be, because the vector is this side, so one component will be this side. It will be FB sin theta. FB sin theta. And here we will have FB cos theta. So this FB sin theta is acting here. So this force FB sin theta will act this side, and which will be exactly balanced by FC. So we have one equation, FB sin theta, it will be equal to FC. Similarly, see bottom surface, FB is cos theta is acting downward, it will be balanced by FA. FB cos theta, it will be equal to FA. Then similarly we can calculate the component of area. Component of area, AB sin theta, it is equal to AC, and AB cos theta, it is equal to AA. And divide them. If we get the components like this, then they divide the components. When we divide these components, we will get, say you can say that this is equation number 1, and we can say that this is equation 2. Divide equation 1 by 2. So when we divide FB by FB by AB, FB sin theta upon AB sin theta, this is equal to FC upon AC. Sin theta cut. So it will be FB upon AB, which is equal to FC upon AC. Then this you divide, FB upon FB cos theta, FB cos theta divided by AB cos theta, and it will be equal to FA upon AB. This will also cut. So we will get FB upon AB, which will be equal to FA upon AA. You can give the name, this will be FC upon AC actually, equation number 3, and that will be equation number 4. Which equation? FB upon AB, and that equation will be equation number 4. Now we can join this, all this, 1 to 2. So FB upon AB, it is equal to FC upon AC, and it is equal to FA upon AA, which will be PA equal to PC, it is equal to P, this is PB, PC. So this is the Pascal's law. This is only the Pascal's law. What we have discussed, the Pascal's law, PB, PC, and PA. So this is Pascal's law. According to Pascal's law, the pressure equally transmitted in all the directions. Thank you. In next period we will discuss about the variation in pressure. Okay, the last line you can keep in mind. Yes. In next period we will see how gravity affects the pressure.